The geometry of the part you're designing will help you decide what feature you'll start with, and in turn which plane to begin your first sketch. Next, you have to create your first sketch. Earlier in the course, you saw the tools that are at your disposal when creating sketches, things like lines, circles, and arcs. You also saw how dimensions and geometric relations can be used to define sketch geometry. Now that you have to create real sketches, one more thing has to be considered, something called design intent. The term design intent is used to describe the behavior of your part model. In other words, how do you want your part to behave when you make changes? I'll show you what I mean in this example. These three circles will eventually become holes in a part. Specifically, they are clearance holes that bolts will pass through. I know that bolts have to go through these holes, but I'm not sure the size of the bolts. The size being considered right now is 1/4 inch, but it might change later. So, how should I dimension these circles? The obvious way would be to put a 1/4 inch diameter dimension on each circle. However, if I do this, what will I have to do if the design changes to 1/2 inch holes? I would have to change the hole dimensions 3 times. Not only is this time consuming, but I might accidentally forget to change dimensions for all of the holes, and if this part goes to manufacturing without being caught, it could become a very costly design error. To solve this, here's a different approach we can use to define these holes to simplify and ensure correct design changes down the road. Instead of dimensioning each hole, I'll dimension only one of them and add an equal geometric relation with the others. This way, if a design change needs to be made, one single dimension change will modify all of the holes. This is an example of capturing design intent. The way I connected the dimension of these holes using geometric relations allows me to make a single change to a dimension and have the part behave properly by updating the other holes. Here is another example of design intent. In this example, I need to center the circle within this rectangle. I know the rectangle is 6 inches by 5 inches. One way to center the circle is to dimension it 3 inches from one edge and 2.5 inches from the other edge. That centers the circle on this rectangle, but does this capture my design intent? Well, let's see what happens when I change the size of the rectangle to 8 inches by 7 inches. As you can see, the circle is no longer centered, so no, this dimensioning scheme does not capture my design intent. So, how can I center this hole so that no matter what size the rectangle is, my circle will always be centered? Well, first, let's get rid of these dimensions. The way to capture my design intent is to use a geometric relation instead. I'll sketch a diagonal line using the center line tool. Then I'll add a midpoint relation between the diagonal line and the center of the circle. Now, no matter what the size of the rectangle, the circle will always be centered. These are examples of how the idea of design intent should be incorporated into your sketches. But design intent is not limited to just sketches. Design intent can be found in any part of a model or design. Some simple examples of incorporating design intent using features would be choosing a through-all end condition for a hole that must always go through the thickness of a part, perhaps a keyhole slot. Or perhaps choosing an up-to surface extrusion end condition to keep two surfaces at the same level. So think ahead about how you want your sketch or model to behave if you make changes, and use that as a guide to help you decide how to define your sketches and features.